Okay, now it's going. So this will be on the YouTube. We'll post it like. All right. So basics. This is really simple stuff. This is just the really basic stuff. We've already done the previous presentations. So does everyone know what an alkane, alkene, alkyne is? They're just the hydrocarbons. So you have carbon chain with hydrogens on it. Alkane. These just describe the highest bond order. Alkane. They're all single bonds. Alkene. So E. They have at least one double bond alkyne, at least one triple bond. It's pretty basic stuff. If it's cyclic, that is, if it's not in a chain, and if it's connected like a circle, then you add a prefix cycle. So when you read something, you know. So cyclic compounds with resonance. You know what resonance is? It's when you have a sort of semi-bond that just transfers throughout the entire molecule. It's then it's written generally as like staggered double bond, single bond.
Wait,
is that the same thing as resonance, where you can have like the bond in even place?
Yeah, that's what resonance is. So those are known as aromatics. They also have a smell. Simplest naming convention, just so you're able to read things. So 2-methylpentane. What this means is you have on the second carbon of the pentane a methyl group. A methyl group is a carbon with 3 hydrogens. You don't need to know these naming things because on the exam they will just give you the chemical equation, chemical formula. So you're all good. But it's just for recognition. The 3 most important functional groups that are used in the exam are alcohol, aldehyde/ketone, and carboxylic acid. Here's a picture of them. Alcohol group is just an OH. Our aldehyde is just an alcohol without hydrogen. So if the carbon and the oxygen forms a double bond, so that's generally done by removing the hydrogen on the oxygen and the hydrogen on the carbon, allowing it to form a double bond. The carboxylic acid is just an aldehyde with an alcohol. Next slide. Cool. All right, so now to the actual thing. Sigma and pi bonds. Every year, there's always one question on sigma and pi bonds. Every year. So if you just quickly go to the next slide, you'll see. So here's 2018, 17, 16, 15. There's one question on each of them. All right, back. Okay, so cool. So sigma bonds are the first bonds between atoms. They're along the axis of bonding. So if you look at this molecule, I'm not sure if in reality it's actually linear, but like it probably is because it's a diagram. So if you look, this orange bond is where the electrons in the sigma bond are. So that's the first bond. They're along the axis. Pi bonds are all the additional bonds. So if you have a double bond, the first one is sigma, the second one is pi. If you have a triple bond, the first one is sigma, the second and third one are pi. And pi bonds are perpendicular to the axis of bonding. So you see the purple and blue ones, those are the pi bonds. So here is a molecule. If you can count the number of sigma and pi bonds, that's an exercise very quickly. I'll just go through it. So you look at, there's 14 sets of bonds, and then one of them is a double bond. So you have 14 sigma bonds and 1 pi bond, because this first one is a sigma and this one is pi, but there are 14 sort of sets of bonds, and then you can count extra. So like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15 bonds, but like one of them is a double bond, you know? So that's 14 sigma, 1 pi. So next slide, let's do the questions. Here are the 4 questions. Run through them. You have a minute. Okay, should be pretty simple. Sigma and pi is pretty simple. There's some more material. It's more complicated that we should go over later. So it might help you to draw.
How many pi bonds are in a molecule?
There's 2 pi bonds, right?
How many pi bonds?
Did you see the answer to the next one?
Michael.
That's a question.
How many sigma and pi bonds are in one? Wait, I have a question. Wait, so you said aldehyde and then you said alkyne. Is that like alcohol?
Okay, so aldehyde is dehydrogenated. So you know alcohol is oxygen and hydrogen.
Yeah.
You remove the hydrogen, and you remove the hydrogen on the carbon that's attached to it, and it forms a double bond. That's an aldehyde. It's a double bonded oxygen. It's also known as carbonyl. But aldehyde is when you have that double bond oxygen on the end of the chain. If you have it in the middle of the chain, it's called a ketone.
Also, the middle of the chain.
So aldehyde, ketone, they are just talking about a double bonded oxygen to the carbon. But it just depends on where they are. And if you want to know the technical term, double bond oxygen to the carbon. Okay, so does everyone have 55?
Okay, isn't ethanol on that?
All right, 50. Okay. Or is everyone good, or do you need a little more time?
For all of them?
Yeah, for all of them.
Oh, I need a second.
Okay, we're gonna go through all the. We'll show the answers and we'll go through any.
Wait, I had no idea that. Isn't ethanol a type of alcohol?
Ethanol is a type of alcohol. It's ethane, so that's 2 carbons, and a nol, so it's an alkane, and nol, so it has an OH group, so it's So C, C, and then hydrogen's everywhere except one of them is an OH.
Oh yeah, alright.
So that's ethanol.
Oh, that's a 4. Okay. Is there anything after the H4?
No, we don't H.
You have ice shot.
That's just a little outside. All right, everyone good?
Was I sitting here?
Is everyone good, or have a general idea?
Yeah,
I think it's A.
Okay, next slide. We'll go through the things. All right. Oh, not isomers. Not. Okay, so all this is simple stuff right now. So here are the answers.
How's it C?
So there's two.
What?
There's anyone need explanations on any questions or all?
Yeah,
good?
Can I read
Yeah.
Okay. All right. So any particular questions? Is everyone good with 55? The
Yeah.
first one.
Yeah.
2018. Everyone good?
Yeah.
Okay. Everyone good with 2017?
No. I don't know how it's C.
So
How many sigma pi bonds?
for so a simple way to sort of think of it is sigma is how many sets of bonds, because it's always going to be, if you have a bond or like a single, double, triple, there's one sigma. So the sets of bonds. So here H2C, that's 2, there's double bond 3, 4, CH5, another between the carbon 6, H7, double bond 8, 9, CH2, so that's 10, or did I miscount? Oh yeah, there's 11 total, but then 2 of them are double bonds, or 2 of them are pi bonds. So there's 9 sets. So there are 11 total bonds, but 2 of them are the double. So you have 9 sigma and 2 pi, and that's C.
Wait, why are there 11 total?
Well, there are 11
Well,
total.
there's 2 pi bonds, so there's 2
Like,
double bonds.
These are double. I just counted that as 2.
Yeah,
I didn't
yeah.
count sets. But there are 9 sets, and then 2 of them are double. So there's 9
Draw the
sigma.
structure.
okay.
You drawing the blue structure.
You want me to draw? I think just drawing the.
Yeah, draw the structure.
Like you could do for like number 1. Number 1's a lot easier. Just be C
Yeah,
double bond
just,
C double bond.
yeah,
Okay.
just draw the structure.
All right, I'll draw 2017. That's not too hard to draw. C. Oh, maybe.
Oh yeah,
These are not
yeah,
very good.
use the
Maybe.
or no, use the brown one. Use the brown
All right,
one.
maybe I'll just do first.
Wait, the brown one is nice. The
So
brown
we have
one.
C. C.
Yeah.
Which one?
Well, there's pi.
It's gonna be
pi.
C triple bond.
I mean,
C
there's 2
triple
pi
bond,
bonds.
C
There's
single
obviously
bond.
2 double
Can it
bonds.
be?
Wait, Alex, they're gonna be Alex. That's gonna be a triple bond on one.
Oh, and also
It
that's
doesn't mean double
bond. The sigma bond has cylindrical symmetry, but the bonding.
Okay, so there's.
Oh, I had no idea. Wait, I thought it was B because.
So you look here. There's sigma 1
What's that
sigma
twice as
bond,
strong?
2 sigma bond, 3, 4, 5, 6 sigma bonds, and then here these second and third bonds are
Yeah,
pi.
it could be C. It could
So
be
you
C,
have
yeah.
1, 2, 3, 4, 5, 6, 6 sigma bonds, 2 pi bonds. Everyone got that? So 2 pi bonds for C, and then you do that same thing for 51. So you just write out the molecule if you want, and then just count the number of bonds. First bonds are sigma. All additions are pi. So if you have a triple bond, 1 sigma bond, 2 pi bonds.
Oh.
Yeah. So that's how it works.
Oh, so
Is everyone good with 2017 now?
Wait, how'd you draw the structural formula?
The structural formula?
Yeah, that's a.
You need to learn how to do that.
This.
Is that the structural formula?
So you don't necessarily need to do that, but you can just read this and sort of see. Like, if you just look at any carbon hydrogen bond, it's this one bond. Like hydrogen can't really sustain. So you have this is just 2 sigma bonds because you have just 2 bonds from 2 hydrogens being attached.
Oh
to
yeah,
carbon.
right.
And you just look through the rest of the thing and you figure it out. Carbon connects 4 bonds. Use your bonding rules, physical science. You can do that. Hopefully not, but okay. Everyone got 2017 then?
Yeah,
We all good? Okay, everyone got 2016? It's the same sort of thing?
Yeah.
Good. What about 2015? Everyone good with that?
Wait, why is 26? Sorry.
2016 C?
Wait, is this like a difference? So it's like
C as opposed to what? D? Not that you're thinking total amount of bonds, but total there are 11 total bonds with only 9 sigma. 2 of them are pi because it's the double and the triple.
oh yeah.
The second and third in the triple. Okay, so for 2015, it is A because that is just because that's the correct. You can just read it first and you see it's correct. If you have sigma bond, it's along the axis and it's like a cylinder and it's like symmetric. So if you go back to the previous slide and you look at the bond, it's symmetric cylindrically around the axis of bond.
It's parallel to the H.
So that's.
Wait, is it the purple one or the yellow one?
It is the yellow one. The yellow one is the sigma one. Sigma is along the axis, it's the yellow one. Okay, and then pi is the purple and blue. It's perpendicular. Alright, 2 slides forward. So I think we're good. Isomers, there's always, or next, go to the next slide, let me see. Okay, there tends to be a question on this generally. Back, so there's one in 2018, 2017. There's not one in 16, there's one in 15. I didn't check 24. Okay, isomers. So there are 2 main types of isomers. The ones you really sort of need to know are structural and geometric. The main classes are structural and stereo isomers. So structural isomers is where they have different structural. So all isomers have the same chemical formula. So like C3H4 or like C3H8. Like so, all the molecules are like C3H8. They all have the same number of their atoms of the element.
Where are they?
So a structural isomer is where the base skeleton, the carbon chain, in this case is structured differently. So, for example, with a base chain of size 6, you have 5 different structural isomers with the carbon sort of connected differently with each other. Stereo isomers are isomers with the same structural connectivity but different group bonding. So, for example, here with this geometric isomers, which are just different arrangement of groups, you have this molecule here, which has both the methyl groups on one side with no hydrogen in between, but here you have a hydrogen in between them. So they're the same chemical formula, but they're a different sort of arrangement of the groups. But if you look, the carbon chain is still a straight 4. There's no off branch. Because these can sort of twist in space. Like the carbon chain is not different, but the groups are different. The methyl groups are arranged differently. And this is in trans. If you've like done bio and looked at types of fats and like trans fat, you know, so there's that. Optical isomers, also known as enantiomers, I think that's how you pronounce it, have different chiralities. So chirality is a somewhat more complicated term. The first time I saw it was talking about particle physics. So it's like something pretty advanced, and you can feel smart just by knowing.
It's okay.
So chirality, having different chirality, is that how you pronounce it? Chirality? Okay. It's where they have non-superimposable mirror images. That is, if you have one, you cannot make it into the other. Like, even though they are sort of like look the same and have the sort of same arrangement. So if you look at this one, if you try to rotate it 180 degrees horizontally, it's not the same thing, because now the NH2 group is in the back, but here the CH3 group is in the back. So they're sort of the same, but slightly different. So they're termed like left-handed and right-handed, sort of. So that's the optical isomers, also the enantiomers. So, but really, you only need to know structural and geometric. These are sort of given as answer options, but I've never seen them asked to actually identify an enantiomer. Yes?
Yeah, I did take a practice test yesterday. That last year's actually. One of the questions did include some sort.
They include I know what you're talking about. In the question, they include chirality, but they didn't include enantiomers. That's why I included chirality, because there was a question.
Yeah, the chirality
is later in the PowerPoint. That's why I added it. All right. Yes.
So just one. So for chirality, you're basically saying like if you reflect it across the x-axis, that it's not totally different, or that
it is totally different. Not superimposable. You cannot make this the same as this one. They're mirror images that cannot be put into each other.
Like a spiral going one way.
So even if you so it's like
it's like your hands. Think of your hands. That's why it's called left-handed, right-handed.
But
they're mirror images. They're like the same thing. But you can't like if you do this, they're the opposite sides. They're mirror images. So think of that. All right, next slide. So here are some questions dealing with isomers. You got a minute. It's not too hard.
The first one was kind of hard.
I don't like know that.
Maybe you have to draw that one out, but you can think of it in your head.
If
Oh,
there's
so
a
it's
chiral pair, do they count as?
So you
Seven
need to look like a little bit.
Because they're type of isomers.
So how many isomers have the formula C2H?
But you generally don't have to deal with that unless you're dealing with like a group, like a methyl group that has like different bond, like electron size, like density, cloud things. You don't have to generally deal with this.
Oh, wait. So you know that test that you gave us, the Olympiad? Do I have to?
No.
Oh, is it just a practice test? Oh, do I have to turn it in? So you're actually gonna so you're not gonna come to what?
Alright, so very quick, does anyone else need a ride to the Olympiad and back?
Wait, but I'm going to school though. I'm going to school though.
They can't come through.
Wait, no, but I'm going to school, but at 10 o'clock, at 9:35,
You can't.
9:45, 9:48. I can't do that.
If you're excused from an hour,
Yeah.
you can't be in the building.
If I'm excused
Yeah,
for an hour.
that's. Alright, cool. These are your answers.
I got it.
So, is everyone good with 56? Everyone good with 56? Anyone need an explanation
I got all
for
of
56?
them wrong.
Wait, why
I
did I
got
get three?
5 right.
Alright,
You
so
put, like, the PRs.
56. I will draw the thing.
The first one or the second one? I was
Uh,
referring to the last one.
Oh,
The last one.
Just
well,
rotate.
they did.
All I know. You guys know.
Alright, that's the thing. So, first one, there are 3 isomers. You have carbon, carbon, that's your base. You can have a hydrogen, bromine, bromine, or you can have bromine, hydrogen, or you can have them like bromine,
Yeah, that's what I did. Wait, so I had a.
hydrogen. Those are your 3 isomers.
Wait, Alex, why is it like, why is it not like this? Why is it on the X and Y axis?
What I drew.
Okay.
You can change it however you want.
Oh, can I write
No.
Oh,
Because you have to fulfill the bonding.
Wait, so when is it like this?
So you have to fulfill the bonding. Hydrogen can only have one bond.
That's like a car.
Carbon has a,
Is that a hydrogen?
in a stable molecule, carbon forms 4 bonds,
Oh.
and then hydrogen forms 1 bond. Bromine forms 1 bond because hydrogen and bromine, if you look on the periodic table, hydrogen has 1 valence forms 1 ionic bond. Bromine is 7, so wants to form 1 bond. Carbon has 4, so wants to form 4 bonds. In a stable molecule, you want to draw. Yes.
Geometric.
So in a stable molecule, you want to draw it so the carbon has 4 bonds.
I'm pretty sure geometric.
Unless it's like a provocation.
How much time do you have for the test?
You have way more than you need.
Thank you.
At most, like no one stays like
There's 30 questions.
everyone ends like 20, 30 minutes before. Like even if the last I've been the last person before and I've had like 20 minutes left. I just stood there because I wanted to get like perfect. Well, and it's like you have way more time than you need. Like everyone leaves like halfway. Maybe not halfway. Maybe like. But you have way more time. And then the show is right after that. Or lunch is right after that. Then the show. So they're great. Okay. Everyone got the second one, 55? 2017? Everyone good with that? Those two are identical because you just rotated 180 degrees and you have the exact same thing.
Wait, you said you can't do that in chirality.
No,
This is
these
not
are not. These
chiral.
are not chiral. These are not. They don't have different chiral.
Oh, okay.
They're not-
Wait, so which ones are chiral?
They'll tell you what you have to do.
I'll tell you.
These are not.
Oh, is it like only
Yeah,
three
they.
elements?
It's yeah. So you just rotate this 180 degrees, the exact same thing. So they're not isomers at all. Okay, they're just identical. Last one, relationship between the 2 compounds. Okay, they are structural isomers because this methyl group is attached to a different carbon in the straight chain. So here, the methyl group.
Oh no. I just had a revelation. Sorry.
So these methyl groups, see the CH3. For here, it's attached to the 3rd carbon. Here, it's attached to the 2nd carbon from the edge. So it's the 2nd carbon. So if you were to draw these, they would look different. One would look sort of like a T. One would sort of look like a I don't know what you call it. Like a stick with the thing near the end.
Ant-Man?
Like a person, a zombie,
Oh.
sideways zombie. So they're different. So they're structural isomers. They have the same
Well,
number of
like,
carbons, same number of hydrogens, and you can just sort of see that.
with 90 degrees.
The things. But they have a different skeletal structure, so they're structural isomers. Okay, next slide.
What is the difference between stereo and structural?
Stereo isomers is class. There are two types of stereo isomers. They have to do with different bonding. So there's geometric isomers and optical isomers. All right, quantum numbers. So like, this is like the only exotic topic I just edited. But like every year, so because this is an order of importance. Every year there's always one question on quantum numbers. Now you go through these like physical science, chemistry, and chemistry, but everyone forgets them. So yeah. So quantum numbers NL, ML, and MS. So N, the first one, first shell, so you're in the first valence, first shell, second shell, third shell. L is the subshell, so that's the type of orbital, so S, P, D, F. And then ML refers to the specific orbital. So if you go to the next slide. Thank you.
No, actually, I'm getting it right from him.
So if you look in the P subshell, you see there are three different orbitals. So that one, M, L, refers to the specific orbital. So this is the 0th orbital, negative first orbital, first orbital. So it's centered around 0 for the specific orbital. So for D, the D subshell, there are 5 orbitals. And so ML can refer to be -1, -1, 0, 1, or 2. If you go back,
5 orbitals. Okay. Wait, so S is just a whole
N, L, ML, MS. So N shell, you're in the first shell, second shell, third shell. L subshell, so S type orbitals, P type orbitals, D type orbitals. ML is a specific orbital in that subshell. So, for example, if you have 1 for L, so that would be the P, and it starts at 0, so 0 is the S. So 1 is P, and then you have a 0 from ML, it's the second orbital. And then in each orbital, you have 2 electrons, and those electrons have opposite spin, so MS refers to the spin. So these are identification for showing you the exact electron. Yeah?
Okay, so this is all on Google Classroom.
It's all going to be on Google, so I'm going to post it.
Okay, so can I study this then?
Sure. If you want.
So
Alright.
electron spin is like, wait, is this electron spin?
You don't need to know about electron spin, you just need to know, like, okay. Next,
It's not.
No, it's not. Alright, next slide.
Don't they always have to be referred to units?
So here are the quantum number questions for the last 4 years. So, you got a minute. Let's see how you do.
You can't have more like this. They're gonna go.
So for 46, the AS, I don't know what that atom is, but it's in the fourth row. So this is asking about an orbital in the 3rd row.
Oh,
So,
arsenic.
or in the
AS
third
is
shell.
arsenic.
Yeah, then what's
It's
the L?
arsenic.
What's the L?
Quantum number. N and L are the quantum numbers. So the quantum number order is N, L, ML.
Oh, yeah,
MS. You generally just need to really know the first 3. N is the principal number. L is the subshell. This is asking you how many electrons are in this specific orbital. Sort of a quick trick question.
It actually is 3 ones.
Yeah,
Should be 0. I'm down.
I don't know. Which will?
Did you send that email to Mrs. Cancer? Cool.
Yeah.
Alright. We can be off by a little bit. Are you guys sure you don't want to do the Olympiad? Yeah. Sure you guys don't want to do the Olympiad?
Are you really sure?
Yeah, chemistry show, you see things explode.
I mean,
Wait, in the
Right,
demonstration?
yeah.
video of this.
Yeah.
Wait.
Yeah, last year they had a thermite, but it didn't explode, and the guy couldn't get it to explode, so he just pulled up a YouTube video of the thermite exploding.
Yeah.
Wait, so
it's pretty
is
sad.
Wait, so it's actually in like a huge like an
It's in the lecture room.
oh, so it's like a huge lecture that goes down like this.
1, 2, 3.
It's in a lecture room.
Huge lecture room
Yeah.
that goes down.
That's where you take the test and where you watch chemistry.
It's like the keyboard.
No,
right?
not
Except with
video.
the-
Except
bigger with a
No, I
smaller
know.
size.
I'm looking for
Yeah. Oh.
this.
Okay. Yeah.
Kiva is designed for like the Native American Kiva, where it looks like that. There's a large.
That's right.
Oh, the Native
makes
American
sense.
Kiva.
Oh,
Okay, wait.
Everyone
so
good
number
with
40
these?
Yeah, I'm all good with everything except for 47. 47 is
I'm
so which set of so which set of quantum numbers NL is it invalid? The only one that should be I mean each one is I thought each one is
So
invalid
for
except
that
for
one,
A.
you have to know
I
where
thought
they
A is the
start
only
with.
correct
N
number.
starts with 1. So you start at the first shell.
Oh, okay.
L starts at
It starts with 1.
0. So
First
0
shell.
is the S subshell. But then and yeah, so it starts at 0. That's the tricky thing. 1 would be P, and for L, and then ML is symmetric around 0.
Oh, that's the answer.
Okay, we're good. All right, next slide.
Yeah, so symmetric.
Thank you. I think ball starts. Wow. Yeah. Okay. You know, I was thinking maybe we should have like a chemistry club brawl stars team.
No, smash.
Yeah, Michael would be like the
Okay, dude, I'll destroy everyone. No, you won't. You just play like.
Anyway, back.
That's like wait, so A is the only one that's not correct?
Running low on time.
Wait, A is the only one that's not correct? Oh.
Yeah.
Wait,
Okay. So everyone good with 2018?
wait, no, wait, hold on. Why is it C?
For
Yeah.
2018?
Yeah.
Because it's talking about
There
an
are two.
orbital. An orbital can only have 2, not 6. 6 is the subshell, and it's like a trick question because it's asking about the orbital, not the subshell. But I mean, it's kind of a bad question because they don't like give you an ML number to give you the orbital. So if they were like ML1, then it would be a little bit easier. But okay. Yeah, it's a tricky.
How many spells you cut?
Everyone good with 2017?
Like 6?
Everyone good with 2017? You have S, P, D, and F subshells, and they have 1, 3, 5, and 7 orbitals.
So there's 2
You have
electrons.
16 orbitals in the fourth shell.
Sorry, okay.
Okay. 2016, everyone good with that one?
No.
A
yeah,
is invalid because this would be
Invalid.
the P subshell, but there's only one shell. So in the first shell, you just have S orbitals. In the second shell, you have S and P orbitals. So this is saying that there's an electron in the P orbital in the first shell, which doesn't make sense. You can't have that.
Yeah, so it
Because
could
it's
be
too
1, 1.
So you can't have that.
Yeah,
So A is the invalid one in 2016. Everyone good with 2015?
Like 2. That'd be just.
Everyone good with 2015?
Yeah.
Okay, it's because like P is this first is 0, 1, so 1 is P subshell. So that's the quantum number is 1. Alright, next slide.
Oh, cause P. Oh yeah, P is the.
Okay, so we've gone through all the things that are generally on every test. These are like every so often. So like most tests or half tests. So oxidizing agents, oxidation of alcohols. So this one's pretty interesting. So oxidizing agents, what they do is they add an oxygen. Now for the first stage generally, what really happens is they sort of kind of add the oxygen, but what happens is they take away 2 hydrogens and form water, and the water leaves. So for example, here, primary alcohol, so the reagents themselves can be pretty complicated, so the person who made this, they just added of that.
Wait a second.
So-
How does this physically? Oh, sorry. How does this actually happen? How does this physically happen?
You have the things, and then they have the forces things.
Yeah, but you said oxidizing agents, so like
Yeah.
it's
Okay,
always
okay,
oxygen.
so
So if you add oxygen,
it's complicated. I don't want to go into it. We're low on time.
oh,
Okay, so what happens is you have your oxidizing agent, and the oxygen comes and takes off the hydrogen off this alcohol, takes it off the associated carbon, and it forms a bond, and you have an aldehyde. Similarly with a secondary alcohol,
Why is
and the
that-
difference between a primary and secondary alcohol is
Oh.
how many carbons the carbon that the group is attached to. So that sounded complicated. So if you see this carbon that the alcohol is attached to, it's attached to one other carbon, so it's a primary alcohol. This one, the carbon that the group is attached to is connected to 2 carbons, so it's a secondary. And a tertiary is if there are 3 carbons attached to this carbon that the group is attached to. So with primary and secondary, it's the same thing. Hydrogen is being ripped away from the oxygen and from the carbon, and you form a bond, and you form a double bonded oxygen. So it's an aldehyde. That's an N. It's ketone in the middle. You don't need to know aldehyde and ketone. That's what happens. Next one. Next slide.
Michael.
Okay, so here's your oxidation ladder. Weak oxidizers only oxidize the first stage. Strong oxidizers automatically oxidize the highest stage. So for a primary alcohol, a weak oxidizer goes to aldehyde, can't do anymore. A strong oxidizer can go from primary all the way to carboxylic acid. So how it goes is for the second stage, it just adds an oxygen into the molecule. So if you look here, see this hydrogen right here, just adds an oxygen there, and now you have a carboxylic acid. So you have your double bond oxygen plus an alcohol. So you can't do this for a secondary alcohol because there's no sort of hydrogen hanging around it.
Oh,
What would have to happen is the oxygen would have to go in between the carbons. So that's very difficult. And there's like a way you can do it, but you're not being tested on that. And that's like farther up. So for a secondary alcohol, you can't do that. A tertiary alcohol, you can't do anything because there are no hydrogens off the carbon. You have to like break the carbon bonds. So like you can't do first stage oxidation here with a tertiary alcohol because you take away the hydrogen from the oxygen, but then if you form a double bond with the oxygen, the carbon connected to it now has 5 bonds. And you can't do that.
Take away
It's
the
very
hydrogen.
unstable. So yeah, that's the oxidation ladder. Weak oxidizers go up to the first stage, it just forms a double bond of oxygen. Second stage is carboxyl, can only happen with primary.
We can only have ketones? So you said secondary alcohol can only have ketones?
Yeah, it can only go up to one stage.
Yeah,
There's no way you can.
You can go up faster, but like.
And also ketones are in the middle.
Okay.
Ketones
are
are
oxide.
outside.
Alright, don't worry about this one. This is about something different. So just this one and this one. So you don't need to know all the oxidizers. I've never seen them actually really ask for that. They would generally tell you if it's strongly oxidized by like copper metal or weakly oxidized. They will generally tell you that. But some you might want to need to know is that anything generally with chromium 6. So basically everything with chromium is a strong oxidizer. The exception to that really is this mix, which is chromium oxide pyridine. But generally with chromium, that is chromium 6, it's a strong oxidizer. Yeah.
Wait, is chromium like corundum? Is that similar?
No. Chromium is a metal. So, 57.
Corundum
So this is a little more complicated, so I'll just explain it instead of just leaving it. Alright, so 57. This is pretty simple actually if you think about it. This is just asking which of these can actually be oxidized. So if you look at it, the only one that can be oxidized is A, because that's a primary alcohol with OH, so you can oxidize it to whatever you want. With B, you can't because it's a secondary alcohol and there's no like hydrogen to rip off to make a carboxylic acid.
Oh yeah.
With C, it's already a carboxylic acid, so like you can't really do anything.
It's weird.
And with D, it's a tertiary alcohol, so there's no other hydrogen on the carbon to rip away and to be able to have the carbon.
A and D look the same though.
A and D, no. D is a tertiary alcohol.
Yeah.
So the carbon the alcohol is attached to already has 4 like non-hydrogen kind of.
So it'd be harder.
So it's only A.
Then it's 58.
Okay.
Yeah, I know B is a ketone.
Oh yeah. So 58. So this is testing your knowledge of oxidation. So this is me asking you, how do you determine something's a secondary alcohol versus a ketone? So if you think about the oxidation ladder, secondary alcohol oxidized turns into a ketone because the alcohol is dehydrogenated and it forms a double bond.
Yeah.
So this is asking what stage it is. Now, if it is a ketone, it cannot be oxidized anymore. If it is a secondary alcohol, it can be oxidized. So what you do is you treat it with acidic dichromate and you oxidize it. So that's how you distinguish it. If you go to the next slide. So like the ketone nothing would change, but with the alcohol something would change. So those are the answers as explained. This is a little different. This is acid catalyzed dehydration. So what it is similar to dehydration is where you just take a water molecule away. With the oxidizer, you add an oxygen and it rips away 2 hydrogens. With acid catalyzed dehydration, you're adding a hydrogen and it rips away a water molecule. So if you have an alcohol, you put a hydrogen and it rips it away. This is a little more complicated. The answer is D because with tertiary alcohols, it's easiest to rip away, easiest to form a carbocation, which is an ion where the carbon has a positive charge.
Ion with
it's a little more complicated. You don't necessarily.
Okay.
It's in just the next.
So ion with the carbon.
So,
ion.
next slide.
Oh, ions could be or carbons could be
Next.
negative or
Slide
positive.
Draw stars and slides.
Yeah,
Okay.
carbons can be
Okay,
positive.
this- Okay, so now we're into like little things that have popped up in the previous tests, but we've gone over the things that pop up every time. So these are like the things that are occasionally. With Olympiad, you discover such a broad range of material.
Yeah,
that,
alkane.
with everything. That's why the first place
go
2
by
years ago was
steps.
44 out of
Go by
60.
steps.
So it does favor the people who don't know anything because they can guess.
You have to go by steps.
Decolorization and approach.
Yeah.
So this
gosh.
is just
Yeah,
when
you have to go by
add-
steps.
So what this all it is. So if you have an alkene, that means you have a double bond, right? So you can that means you can add bromine into it. So bromine, if you remember, naturally forms Br2. It's a what's it called? Diprotic?
Diatomic, yes.
Diatomic.
Mhm.
So it's diatomic.
Mhm.
So when you take an alkene and you put it into a bromine solution, the bromine is absorbed by the alkene, and bromine is naturally red-brown. So the
Really?
absorption shows itself in the
Liquid
decolorization.
bromine?
So you have 2 bromine solutions, you put an alkane into it, nothing happens because nothing happens with the alkane and the bromine. The alkene, you put the bromine into it, the bromine is absorbed by the alkene and it forms an alkane because now the double bond is broken and that's like an alkane with bromine in it. And so it clears up. So that's that's decolorization of protein. So
What?
2018, it showed up.
Wait a second.
Yeah, this one was
The first one has to do with chirality.
Wait, can we have a physical demonstration in the
We can not right now.
I mean not right now obviously, but like in the Kiva?
Mine.
No, I meant at the Kiva.
I don't know.
We're gonna have
Oh yeah, I got 58 right. I got 58
we're
right. I'm so happy.
Get ready. We might have to
yeah.
Okay, chirality. So,
Again, please let me.
but so we're going over orgo and biochem, which is coming up later because this is stuff none of the chemistry students learned by the time of the Olympiad. Organic chemistry is not in so you don't get to organic chemistry by the time period of chemistry Olympiad. So this is material that no one else in the Olympiad in the room will know. So that's why we're going over it because none of you know this. So it's all new to you, right? Because otherwise you might. So chiral molecule, what you're really looking for is something that has a group off the carbon. So this is a little more complicated. So you have 4 hydrogens. Where can you replace the hydrogen with bromine to give a chiral molecule? It is okay. So let's see. It is HC because with HD, think about the molecule, it can still sort of be rotated around and still be fine. Like if you have a carbon and the 3 hydrogens in like a trifold, it doesn't really matter where the bromine is, it's sort of the same. With HC, it's different because you have the carbon electron groups sort of like repulse in a way so that if you have hydrogen and the bromine and you have them on one side, it's different than the other side. But it's mirror images.
Alex, it's very
But
interesting.
here it's sort of rotatable.
It's a complicated question.
Wait, this is very interesting, but how many more slides do we have?
A few more slides, I don't know.
Oh, well, guess what? My parents are actually calling.
Alright.
Alright, so Alex,
I'll post it.
so 9:45, just picking up right now.
Okay.
Wait, do you really want to?
Not at 9:45 at the first hour. 8.
No, I'm not gonna be at school. I'm just gonna go. Yeah,
Oh.
just pick me up from my house at 9.
Okay.
9:45.
Give me your
Yeah.
address. I might have to pick you up a little earlier, so I'll pick you up 9:30.
Yeah. Remember when you got me? Oh, you're far.
Yeah. So if I don't see it, so give me your address. Okay. So it's that's chirality. With B, I mean, if you replace the B with a bromine, you're not really getting anything chiral. It's just there. I mean, there's nothing else. It's just carbons. It's there. You can symmetrically, it works fine. With A, it's sort of the same thing. You can just rotate it around and it's fine. But here you can't because because you have the carbon is restricting it. The 2 carbons that the carbon is attached to restricting it. You can't rotate.
Yeah, I got your
I'll just.
Wait, just hold your phone.
I don't want to hear.
Okay, fine. Okay, do you want my phone?
Alright, no, it's fine. Alright, 58, 2018.
Are you sure?
I'm fine. Yes.
I can give you
2018,
it.
question 2. Compound with formula C6H12 does not decolorize bromine in a CHCl3 solution. Which compound could this?
A.
So,
A, because
it's not an alkene. Yeah. Next slide.
all of these are like all of these do add up to C6H12. So if you're dumb like me and try to like draw all of them out and then figure out which one isn't gonna be like C6H12, that is not the answer. That's not how the way it is.
So those are the answers. Those are the explanations. Next slide. Someone. Thank you. Biochem sorted. Okay. Biochem tends to vary. So these are just all the questions for the last couple. There's always one. There's one or two biochem questions on each test. They sort of vary on what they talk about. It's just biology, maybe biomaterial. We'll just spin through these really fast. So this is the only biology question on 2018. It's pretty simple. You know what endothermic and exothermic is?
Catabolic
Exothermic. It forms sugar. This is pretty simple. Next slide. Someone.
Oh, and
It's not A.
2017 first question. Sequence of amino acids and proteins goes primary structure. Quaternary structure. So the structure is in the order of like connection. So primary is where you have just the amino acids connected to the chain. Secondary is you have the global filling of the chain into helices or sheets, and then it continues on to the primary style stuff. Next slide. Okay, so this is asking you which molecules from which of these class of biopolymers can react with water to form smaller examples of them. So which of them can be sort of split into the smaller units of them through with water. So the answer is both. So with what is it, proteins or like chains of amino acids, you can split them up by adding water, and it breaks the peptide bond. And with sugar, you add water and it can break up the sugars. 2016, what two forms are found? Bases are found as hydrogen bonds, base pair, and DNA. So it's the A bonds to T, C bonds to G. Just have to memorize. A, T, and C. The only option, the other option is A. Yeah.
Also in RNA, T replaces U, so wherever you see a U, that's for RNA, it has to be A and U.
Okay, 60, what is the nature of peptide bonds in the protein? What they are amide bonds. So they're, if you go back a slide, look at it. So if you look at this peptide bond, this is an amide. It's where you have a nitrogen and a carbon double bonded oxygen. That's the amide here. So next slide. Next slide. Okay. Which of these forms is not classified as biopolymer? So polymer, poly, it's multiple in a chain. So ketone is, I think, it's what makes up insect shells. So by the scale of insect shells, you can probably tell it's more than one molecule, or more than one like little small unit. So the only one is glucose, because glucose is just like it's small sugar. Collagen is connected, is a bunch of connected things. Cellulose, a bunch of connected things. 2014, these are the two biochem questions. Which element is not found in amino acids? Phosphorus, because like everything has hydrogen, oxygen, and then you can just see amine. So like nitrogen, obviously amine means it has nitrogen in it. For 60, which of the following is not classified as a carbohydrate? The answer is glycine. Glycine is an amino acid. Starch is just a bunch of the carbohydrates together. Glucose, lactose, and sugars, which are carbohydrates. Okay, so that's the end of the presentation. We got 5 minutes left. I don't know if it's
If not,
Tomorrow's gonna be a blast. We're gonna have so much fun. It's gonna be great. We're gonna love it. Tomorrow, hopefully they